Have you ever wondered just how far away everything is in space? Let's find out. We're going to be making a model of the solar system and use it to explore just how big space really is. When measuring distances in our solar system, we use astronomical units, where 1 AU is the distance between the Earth and the Sun. In my model, I set 1 AU to be 2 steps, or about 2 meters. If you want to make a smaller model, you can use any scale you like, perhaps the width of your hand. You can also use any object you like to represent the planets in our solar system. So let's start with the planet closest to our Sun.
Mercury is similar to our Moon, with a cratered surface and very little atmosphere. Interestingly, a Mercury solar day is twice as long as a Mercury year. Venus is the second brightest object in our night sky after the Moon. Because of its dense atmosphere and proximity to the Sun, it is the hottest planet in our solar system, reaching over 460 degrees Celsius. Now, Earth is in the Goldilocks zone, which means it's not too close to the Sun and not too far, it's just right. It's also the densest planet in our solar system. Mars gets its colour from the iron oxide on the surface. Its sky is pink and its sunsets are blue. It also has the highest mountain in our solar system, a 21 kilometre high, 600 kilometre wide volcano called Olympus Mons. Jupiter is bigger than all the other planets combined. It has 79 moons and a giant storm called the Great Red Spot that has been raging for 350 years. Saturn has more moons than Jupiter, and we keep finding more. The rings, which are predominantly ice, are 282,000 kilometres wide but less than a kilometre thick. Uranus is tilted so much that it appears to be rolling along its side. It has 2 thin rings and is actually the coldest planet in the solar system, reaching minus 224 degrees Celsius. Neptune has methane in the atmosphere, which causes it to appear very blue. It also has its own storm spots like Jupiter, but they have the fastest recorded winds in the solar system. A year on Neptune is 165 times longer than a year on Earth. Now, our model of the solar system isn't quite accurate. So the distances to the planets are fine, but the size of the planets are not. So for my model, the Sun would have to be 2 centimetres tall to actually be accurate, and the Earth would have to be as wide as a human hair.
We can then think about our next nearest star, Proxima Centauri, which is a small star about 4 light years away in the star system Alpha Centauri, the brightest star of which is Rigel Kentaurus. This is one of the pointer stars near the Southern Cross. In my model, Proxima Centauri would be just 1.5 millimetres tall and would be very far away from my model in Melbourne, somewhere between Canberra and Sydney. Now, seeing as we can't simply take a tape measure into space, you're probably wondering how we can confidently measure such large distances. Well, we have something called the cosmic ladder, which involves using different methods of measurement depending on how far away an object is. If an object is close, so within a few thousand light years, we can use parallax. You can test out parallax yourself. Hold up an object and close one eye. Look at it carefully, then close the other eye. The object appears to shift to the side in comparison to the background. We can measure the angle between these 2 apparent positions and then determine the distance to the object using simple trigonometry. As Earth moves around the Sun, a nearby star appears to move in comparison to the background distant stars. So we measure its distance using parallax. This is how we know Proxima Centauri is about 4.24 light years away. That's 40 trillion kilometres. And remember, that's our next nearest star to the Sun. If an object is too far to see a parallax shift, we can use something called a standard candle. There are objects in space that are always the same brightness, such as Cepheid stars and Type 1a supernovae. We can measure their luminosity by measuring how bright they appear to us. Test it out yourself. At night, turn on a small light like a lamp. Now standing close, it appears very bright. As you walk further away, it gets fainter. Doubling your distance reduces the brightness by a factor of 4. So we could measure the distance to stars far away within our galaxy, the Milky Way, by measuring the luminosity of a standard candle. The stellar part of the Milky Way is over 100,000 light years wide. In our solar system model, with the Earth being 2 steps from the Sun, the Milky Way would be over 1,000 times bigger than the actual Earth. And that's our model. The real Milky Way is 75 trillion times wider than the Earth. To measure distances to other galaxies, we use redshift. The universe is expanding, and so when rays of light travel through the universe, they also get expanded, so that their wavelength gets longer. This means blue light might get stretched into green light, and green light might get stretched into red. We can measure how much the light has been stretched, or redshifted, and that will tell us how far away the object is. The Andromeda Galaxy, our closest galactic neighbour, is 2.5 million light years away, much too far to add to our solar system model. So, even when we're making such a small model that the Earth is no wider than a human hair, it's impossible to comprehend just how big everything in space really is. Why don't you attempt your own model and see what else you can add to it? In the video description, we've got instructions on how to make your own solar system model. There are a lot of other objects in the solar system that I haven't included. Can you figure out where they should go?
Astro 3D is the Australian Research Council's Centre of Excellence for all-sky astrophysics in 3 dimensions. Our astronomers are searching to understand the evolution of the matter, light and elements from the Big Bang to the present day. This Astro in the Home series is your opportunity to unlock the secrets of the universe with your own 2 hands. Find out more by visiting our website, following us on social media, or subscribing to our YouTube channel to be notified whenever we upload new content. Now, go explore the universe.